Hello guys, Assalamualaikum. It's me, Fadhli Mubarok. We'll discuss to you guys for question from examination of chemistry 9702 Cambridge International Education. For the first question, first let's convert the masses to mole 0.80 grams of methane divided by its molar mass of 16 gives us 0.05 moles. For water, 1.35 grams divided by 18 gives us 0.075 moles. Now we must find the limiting reactant by dividing the moles by their coefficient. For methane, 0.05 divided by 1. For water 0.075 divided by 2 is 0.0375. Since water has the smaller ratio, it's our limiting reactant and we will run out first. Using the molar ratio, the molar moles of hydrogen will be 4 and over 2 times the moles of water, which equals 0.15 moles, 1.15 moles. Finally, multiply this by the molar gas volume of 24 and we get exactly 3.60 decimeters cubed. The correct option is B. For the second question from paper 1 question 7. First, we rearrange the formula to find the number of moles N equals PV per RT, plugging in our numbers. For 103,000 times 5.37 cubic meters divided by the gas constant 8.31 and the temperature of 330 Kelvin, that gives us exactly 0.20 moles. To find the mass, we multiply these moles by the molar mass of 16 grams per mole, which gives us 3.2 grams. So the correct option is D. For the third question is from paper 1 question 9. We use ideal gas equation again. N equals PV per RT and we insert the number and we get value of 2.34 times 10 the power of minus 4 mole. And for the concentration, we divide it into 0.2 decimeter cubed and we got the value is 1.17 times 10 the power of minus 3 mole decimeter cubic. For the fourth question is from paper 1 question 11. The structure of sulfur dioxide is non-linear because it has 5 lone pair. And then for the next question is from paper 1 question 14. Ammonia reacts with acids to form the ammonium ion. Which row is correct? The correct row is tetrahedral and the degree is 109.5 degrees. And then for the next question is from paper 1 question 17. We use the delta H formation formula equals delta H formation equals sigma delta H reactants minus sigma delta H products, and then we insert the number and we got the calculation, the value of minus 1,506 kilojoule per mole. The answer is B. And then for the next question is paper 1 question 18. We use the formula delta H reaction equals sigma delta H products minus sigma delta H reactants. And then we insert the number and we got minus 134.9 kilojoule per mole, and the answer is B. And then for the next question is paper 1, question 19. We use the formula is minus 158 equals 2 times x plus 3 times minus 286 minus 1050 sorry, and then we got 2x equals minus 860, and for x we got the minus 430 kilojoule per mole, and the answer is C. And then for the next question is paper 1, question 20. We use the formula delta H formation equals sigma delta H combustion for reactants minus sigma delta H combustion for products. Delta H formation equals minus 394 plus 2 times minus 286 minus 726. So the answer is C. Why the minus 286 is times for 2? Because in the end of equation the coefficient is 2. And then for next question, paper 1, question 21, delta H equals the delta sigma bonds broken minus sigma bonds formed. For the sigma bonds broken, we calculate the number is 2 times 410 plus 840 plus 2.5 times 496 minus 2 times 460 plus 4 times 740, and delta H equals 2900 minus 3880 equals minus 980 kilojoule per mole, and the answer is A. And then for the next question is paper 1, question 22. In the conversion of compound X into compound Z, it was found that the reaction proceeded way of compound A, which could be isolated. The following steps were involved. For X to Y, delta H positive mean that's endothermic, and for Y to Z, H delta H for negative, it means exothermic, and the answer is A. And then for the next question is from paper 1, question 23. This question is same like paper 1, question 18. You can play back the video if you will see the formula and the correct value. And then for the next question is from paper 1, question 25. Okay, this question is give us the equation for a neutralization, and then produce 2H2O, and then By using this information, what is the most likely value for the enthalpy change of the following neutralization? For the second equation, is still 2H2O, and then the answer is same. The answer is minus 114 kilojoule per mole. And then for the next question is from paper 1, question 26. We use formula delta H reaction equals 2 times plus 2 times 296.5 plus minus 791.4 equals minus 198.4 kilojoule per mole. The answer is D. And then for the next question is from paper 1, question 27. We use delta H total equals minus 904 plus 2 times minus 114 plus minus 348 equals minus 1,480 kilojoule. And for delta H per mole, we divide it into 4 mole equals minus 370 kilojoule per mole. The answer is B. And for the next question is from paper 1, question 28. We use the formula Q equals M times C times delta T, and we insert the number, and we got the value is 522.5 joule. And then for the mole, we use the formula is N equals M times V, and then we insert the number, and we got 0.0025 mole, and then we use the equation delta H equals Q divided by N, and then the Q is Q and N is input, and then the value is minus 209 kilojoule per mole. And then for the next question is from paper 1, question 29. For mole of NaOH is 0.03 and times by 2 mole, and then the value is 0.006 mole. For the Q is 3,420 joule, and we use delta T equals Q per divided by M times C equals 16.26 degrees Celsius, and T final is 25 plus 16.26 equals 41.3. The answer is A. And then for the next question is from paper 1, question 30, and we use the formula of delta H reaction, and we insert the number is minus 2,820 minus 2 times minus 1,368 equals minus 84 kilojoule mole, power of minus 1. The answer is B. For the next question is from paper 1, question 34. Which row gives the identifier of P and Q For the P, we can see the answer is C is hydrochloric acid because it's strong acid, and for Q is barium oxide because it's a strong base. And then okay, for the final answer is C. And then for the next question from paper 1 question 35, in which reaction is water behaving as a Bronsted Lowry base? And the answer is B, because H2O is H plus acceptor and H3PO4 is H donator. And then for the next question is from paper 1 question 36, in which reaction is the underlying substance acting as a base? For the final answer is C, because base is H plus proton acceptor. And then for paper 2 question 1, for charge on plate from the left side is plus because the electron is minus, the charge is minus. And then for protons, the charge on plate beside him is minus because proton have plus charge or positive charge. For the line, a separate beam of neutrons from the same source behaves in the same electrical field is shown is vertical line between electrons and protons way. And then for the B is number of orbitals from atom Kr 36 is number of orbital in S is 4, in P is 9, in D is 5. And then for the B2, complete the diagram to show the number of and relative energies of the electrons in an isolated atom of silicon is 1s2, 2s2, 2p6, and 3s2, and 3p2. And then for the next question, for describe how an atom of chromium 54 differs from an atom of chromium 52. Revert to numbers of particles in your answer. The chromium for the chromium 54 have more neutron than chromium 52 because contain bigger atomic relative mass. And then for the B is for the B2, this the total number of unpaired electron in an atom of chromium is 4. For the next question is okay. The shorthand electronic configuration of cobalt is AR 3D7 4s2. Identify what is meant by AR by giving its full electronic configuration. For the full electronic configuration from AR is 1s2, 2s2, 2p6, 3s2, and 3p6. And then for the A2, the lowest energy electron in cobalt are in the first orbital. Draw the shape of 1s orbital is circle, and then deduce the number of unpaired electrons in cobalt atom as 3. And then for the next question, divide relative atomic mass. The relative atomic mass is 1 divided by 12 of average mass atom C12. And then for calculate the relative isotopic mass of the third isotope of iron in the sample. Show your working is the formula is 55.8 equals 53.6 sorry point 9 times 6 plus 55.9 times 91.6 plus x times 2.1 divided by 100, and we got the value for x is 56 times 85, or we can say that the answer is 57. And then deduce the number of pairs of electrons in the 3D subshell in iron is 1. Sketch the shape. The sketch is like this, like circle. And then for the next question is define enthalpy change of formation. Is the heat absorbed or released when 1 mole of a compound is formed directly from its constituent elements in their most stable standard state. And then for the next question is enthalpy change of formation. We use the Hess law for this is like this, and the equals is minus 24 times 8. And then for the next question is predict the shape of a bond angle in a molecule of StL2 by using Fies EPR theory. For the shape is bend, for the bond angle is 109.5 degree. For the drawing is like this, you can see. And then for the last question is enthalpy change of formation, and then we use the formula is delta H is equals to before that we equate the we balancing the equation first, and we got the like this, and then we use delta H is equals delta H products minus delta H reactant, and then we insert the number, and we got that the answer is minus 230 kilojoule per mole. Okay, thank you for you guys for listening me, and thank you for Ustazah Helen because of teaching me. I'm sorry guys if I cannot explain to you not clearly. And then me is always challenging myself to get to understand the chemistry. Thank you guys. Assalamualaikum warahmatullahi wabarakatuh.